Hi everyone, my name is LiuZhuo. Here I'm presenting my final project, Oryx Opensource Real-Time Large-Scale Machine Learning Predictive Analytics Framework. So here's an outline of what I'm going to talk about. I'll first introduce the Oryx, what is Oryx, what it does, and what the infrastructure looks like. And also, I'll give an example using Oryx 2 to build a recommender system for a music website. And then I will summarize the pros and cons of the Oryx. So, what is Oryx? Oryx was built from Cloudera. It's an open source, real-time, large-scale machine learning project. It was intended to build, serve, and update the models in one place. About 90% of the code of the Oryx version 1 was from the Mirix. Mirix was in a Perch project since 2011 to build the recommender systems. And I think in December 2013, Cloudera bought the Mirix. So most of this code for its first version was carried over from the Mirix. And Oryx also implements the Lambda architecture, which combines the advantage of both the batch and streaming process. And the Oryx 1 was built upon the Apache Hadoop, and Oryx 2 was built upon the Kafka and Spark. And also, it comes with the model queries via an HTTP REST API, and you can also update the models very closely in response to this new streaming data. The models are also exchanged in the predictive model markup language, so it's very easy to use and build the applications. And in the most cases, I found that Oryx was built for the recommended systems. So, what does the Oryx is trying to solve? As we can imagine that for the lots of cases in our predictive analytics, and if it was happening in the lab, in the most cases it was question driven, and you have a fixed data, and then you run the report, and you build up a scoring engine. However, in a factory model, most of the time it requires an automated processing, and you really get a fluid of the data. And so in this case, you really need the production applications. So this comes to a question of how to productionize your machine learning algorithms. So of course, and you can run your batch models offline and update your models at night, and then you got the models. But they are really the cases that you need the real-time processing. For example, if a customer goes to an Amazon website and it was click through on the products and searching for the products, you really want the recommendation of the product upon their visit and upon their clicks to get an updated profile of what the customer is trying to get from your website and what they really need. So you really need the real-time recommender systems to solve this problem. So Oryx is trying to build model and serve model and update the models in one system. As you can see from the shown over, the director of data science and Cloudera, who is building and contributing for this project, mentioned that the Apache Mahout has reached the end of its road. It's stuck in a batch-only first-generation MapReduce era, and it requires a lot of work on users' parts to get a working system in place. So here is an overview of what the first version Oryx structure looks like. It was claimed to be a simple real-time large-scale machine learning infrastructure. It was built upon the MapReduce framework. So its two functionalities is one is to build the model, the other is to serve the model. So here you can see that you have the computation layers here and to connect to the Hadoop system to build the models, and then you also have a serving layer that reads in the input and also get your output from your HDF system to serve your client. The Oryx 2, the interesting thing is that it's not a succession of Oryx 1, it's a reconstruction of the whole system, so it's completely different and independent of Oryx version 1. It built a Lambda architecture based on the Spark and the Kafka, and also replace the MapReduce algorithms with the MLApe, and it's emphasized the real-time update with the Spark streaming process. So here you can see that the majorly has the 3 layers: one the batch layer, the speed layer, and the serving layer. So here is how it works out. You get an input and it gets through the serving layer, and serving layer pushes it to the Kafka input topic, and then your batch layer get your recent input to, and it combines the recent input with your historic input in and batch processing to produce the models, and the model was pushed to the update topic in Kafka. And then the models was also pushed to your speed layer, and your speed layer also get the recent new streaming data in order of seconds. And it also update the model and push updates to the model update topic in Kafka. And then in the end, the serving layer, the user will send the query to a serving layer. So the serving layer would query both the models and the model updates and send it to your end user. So here's an example of how to build a recommender system for music website. So the data that we have here contains 92K artist listening records of about 2K users from the Last.fm online music website. The file contains the data of the counts for each user and the artist pair. Here's how we start to build up the system. So first we need to set up all our clusters, and so the Oryx 2 requires these Apache Hadoop, Zookeeper, Kafka, Spark, and Java versions. On this website, it says that you can use the CDH 5.4. That would meet all the requirements, but I found that it's still missing the Apache Kafka, so you still need to download a Kafka to run the models. And after we get all our hardware set up, we need to get the most recent Oryx 2 release. So you go onto this website, get Oryx 2 alpha versions of your compute path shells and your run shells and your jar files for your batch, serving, and your speed layers. And note that you have to change your Hadoop configuration directory and CDH jars directory in your compute class path sh file to make it according to make it the same as what you have in your system. And then to run a recommender system, we need the Oryx configuration files for the AOS example file. And so you get onto this website and download it. And here is something that I wanted to mention, that you can also make modifications of these configurations. Like for the batch streaming process, you can set up what are your interval of your model generation seconds. You can try to shorten it. These are just examples of what I used. Also, it appears that you need at least either 2 number of executors or 2 cores to run the Oryx 2, because remember that when we get back to the Lambda's architecture, that you have the 2 topics from your Kafka, so it needs at least 2 of either of these. Because I have overload memory in my Mac, so I just put it as a 2G of memory, but you feel free to enlarge it if you want to. So now we've got our hardware and our software files, and really we need to prepare the data and start to run our Oryx. So on the Oryx 2 instruction, it says that you have to change all your data to your CSV file. So here's how we do it through the command line. And then we start our Kafka by running the Kafka server start shell file, and then you need to create the two topics as we mentioned before in the Lambda architecture. The one is the topic for the Oryx input, and the other is for the Oryx update. Also here, optionally, you can set up your retention time for your Oryx update. And then the third step is to start running your batch speed and serving layers of your Oryx 2. And after all of these servers are started, you use this wget command to push your input data to a serving layer. So then now you just wait for the result. So here is what the result will come out. It will create a path that you set up in your configuration file, and it will create the data and also a model director to store your model results. You can use Hadoop FS dash text to look at those results closely, and you can also use the wget command in your Linux system to query the model results. But here's also a good functionality via an HTTP REST API, and you can use the just put these into your browser, and there are lots of functionalities you can use, like a recommend, similarity, most popular items, and most active users. And you can just simply put these into your browser. You can query the model result. For example, you can see what are the music artists that's recommended to listener number 5, and what are the most popular music or top 8 music artists. So you can also use the wget command to check if your model updates is ready, if you're telling your model update. And once the serving layer pick up your model updates, it should show an 200 OK here that your model update is ready. So the conclusion is that the Oryx 2 is really a seamless real-time streaming application at scale, and because it's built upon the latest technology of Kafka and Spark, it's really reliable and efficient. And it also help you test and train the split, the data, and you can also tune the hyperparameters. The HTTP REST API is very good applications that provides the set of end-to-end machine learning applications, and it's also extendable. You can use Oryx 2 to provide the platform for building other Lambda and machine learning based apps. However, this Oryx 2 or Oryx 1, they provide very limited algorithms and applications. It now only includes LS, K-means, and random forest. It has very limited usage in industries, and I know there are also other companies, they are building their own recommender system too, so it might face some competitions. Alright, that's all about it. Thank you for listening.